Today I want to show you all where we can find sine, cosine, and tangent on the unit circle. So here I have a unit circle, which we know has a radius of 1. So as long as I draw our radius to our center, we can say that any point on the unit circle will have a radius of 1. So why don't we start with that information? Okay. Now, I'm going to talk about sine first. Sine, we know, is opposite over hypotenuse. But we don't have a right triangle in this graph. So I can actually just make one. If I draw some vertical distance downward, I've now formed a right triangle with the x-axis. And this red line is effectively our y-axis, or part of it at least, but it's just shifted over. So even though I don't know the exact value of that red line, I do at least know that it is a component of y. So I can actually just plug that information in and say, well, the opposite is y, and the hypotenuse is 1. And where did that 1 come from? That's just because the hypotenuse here is the radius. So our sine theta is really just y. So I can replace that y with a sine theta. Now, cosine is, in a sense, engineered the same way, only that I'm now dealing with a horizontal component. So I want to call this distance here cosine theta. And it kind of makes sense for y, because I know cosine is just adjacent over hypotenuse, and relative to our reference angle, our blue line is the adjacent side. And that adjacent side is just a component of x. It literally lies on the x-axis, so I can just call that x over 1, which is just x. So let's say x or cosine theta. But what about tan theta? Well, I know tan theta is equal to opposite over adjacent. I know that's true, but I also know it's equal to sine theta over cosine theta. And we actually found those values. I think it's easier to see this way instead of saying opposite over adjacent and then plugging in values, but we found y and x, so tan theta is really just y over x. So why don't we think about this for a second, right? If my sine value was growing arbitrarily larger than our x value, it would make sense for our tan to increase. But if our sine value was to arbitrarily decrease, and I don't know, our cosine stayed the same, our tan is just going to shrink. So this really is just the relationship between the distance of our x component cosine and our y distance sine. So to picture that, I'll first denote that tan theta exists here, and the word tangent really just means a line that hits a circle at one point. So actually it makes sense for it to exist right here. But I want to talk about theta for a second, and I also want to show some applications of tangent. So I'll go to GeoGebra, and here's a little applet that I think can help create a visual. Here it tells us theta. Now, it doesn't label it, but I know this is 45 degrees. And that's because in our blue parentheses, we have cosine comma sine. Cosine equals 0.71, sine equals 0.71. Tangent is the relationship of sine divided by cosine, and any number divided by itself is 1. So our tan theta is equal to 1. And if we look at the individual distances, now it's kind of hard to see because secant is covering part of cos, but that distance is the exact same as our sine distance. But if I change it where sine is increasing, as I mentioned earlier, our tangent will also arbitrarily increase. But if I decrease sine, our tangent decreases as well. So that's just something to think about. But what about theta? What can we say about its values? And here I have another applet. This might be better to see where our cosine is, because if I check off the secant box, it just blocks it almost. But cosine, or not cosine, sorry, sine theta is equal to cosine of 90 minus theta. And that is one of the cofunctions that we are told in school. Now, similarly, I could write down, well, cosine theta equals sine of 90 minus theta. Or I could say that tan theta is equal to cotangent of 90 minus theta. But if I go back here, right, it makes sense why I'm subtracting 90, because we have a right angle right here. And really, at the end of the day, that's all you need to know about the locations of sine, cosine, and tangent, and a quick little relationship of theta relative to our cofunctions. I hope you all have a good day, and take care. Bye-bye.